Alright, boys and girls, Mr. Arnold here. We're going to take a look at density and understanding density graphs and density curves, just making sure we see what is actually going on. I tried to record this earlier, it didn't work, so I'm going to try to record this now. Harrison, high five, nice job, buddy. Hopefully the sound will come out on this one. We'll find out here in about 5 minutes or so. Just as a reminder, talking about density here, density equals love. And when we talk about why density equals love, if we take a heart and we divide the heart in half, we've got the top part of the half that looks like M, which stands for mass, and the bottom part looks like a V, which stands for volume. Yes, that says mass for those of you who are worried about what I'm writing up on the board. I just noticed that as well. Thank you. So, again, density equals mass divided by volume, or density equals love. We can do it in a shortcut format where we put the D here, the M up top, and the V here, and we put the little multiplication sign there. What this does is helps us figure out how to solve for any of the variables. All you have to do is cover up the variable. If we cover up the variable, we look at volume. Volume is equal to mass over density. So that's how we would solve from volume, etc. From there, just cover up the symbol that you didn't want, and then you can actually see how that would look like. So this is it, shortcut way, and again, density equals love, or mass over volume. Density is nothing more than how much stuff, how much matter there is in a given space. So how many particles are packed into a given volume or a given space. One of the key things that you need to kind of remember is water. Water has a special density, and the density is 1.0 grams per milliliter, which means anything that is higher than 1.0 will sink in water. Anything that is lower than 1.0 will actually float. So if you get asked the question whether an object will float or sink, you simply need to figure out its density, compare that to 1.0 to find out from there. Another thing that you will see is what looks to be grams per cubic centimeters. It depends on if the shape is regular or not. If the shape is regular, and by regular I mean has length times width times height, a square, a cube, something along those lines, you can calculate that in cubic centimeters. Centimeter times centimeter equals centimeters cubed. But the overall thing that you need to remember is 1 gram per milliliter is the same as 1 gram cubic centimeter. They actually fit. If I take a box and I make it 1 centimeter long by 1 centimeter wide by 1 centimeter high, I fill that box with water, it will actually equal 1 milliliter from there. So that's a little bit about density. Now let's take a look at what's going on with these density graphs. Based on the density graph, again, we have mass over volume, just to keep us in line here, grams over milliliters, as we're talking about that. If we take a look at density graphs, the slope will tell you everything you need to know. If you take a look at the slope of A compared to the slope of B, the slope of A is not as much, or is not as great, it's not as steep as B, therefore A is less dense than B. If you take a look at B compared to C, you can see that B is less dense than C, but if we compare it to A, it's actually more dense than A. And then if we take a look at our slope here for C, C is going to be the most dense because it is also the steepest of the slopes. So by generally looking at a density graph, we can tell which one is more dense or less dense than the other objects that we have going on there. One of the questions that we will see, or we will get later on, is what happens if we want to try to balance these items out. And if we try to balance these items out, we're going to put them on a balance, and we're going to see if we can actually equal those substances out. Now again, we're talking about in milliliters, and so milliliters is a function of volume, so we may have more or less mass packed in, which may make the balance move one side or the other. Let's just say we're going to use 10 milliliters of A on the left-hand side. If I put 10 milliliters of A on the left-hand side, what I want to know is how much B do I need to balance that out. And in order to do this, what I need to do is figure out, let's just say this is 10 milliliters. I'm going to come up to my A, So I put this much A in there, but I want to know how does that relate to B. So I'm going to come to right about there, and if I follow down, what you'll notice is it's about halfway there, so that's about 5 milliliters. So if I put 10 milliliters of A in, and I draw that over to my B line, what I notice is I need about 5 milliliters of B to cancel that out. And that should make sense because A is less dense. It has less stuff inside its volume. There's not as many particles. So I need not as much B as A in order to get those to balance out. If I wanted to take a look at that in terms of C, so what about C now? How much C do I need? Again, I'm going to come up, I'm going to come across, and I'm going to see where I hit my line C at, and I'm going to draw that line down, and you notice it's about halfway in between A, or halfway in between the original spot and where B is, so that's going to be about 2.5 milliliters. And that should make sense because C is the most dense of all of the substances that I have. Since C is the most dense, it has the most mass crammed into a smaller space. Therefore, I don't need as much volume to get the same amount of mass as A or as B, etc. from there. So just, again, using these, we can tell which one's the most dense, which one's the least dense. We can also tell how much milliliters or how much volume of each we need in order to cancel each other out by simply going up to the line of the known, measuring over to the line of the unknown, and then checking out the volume from there. If I was to put A, B, C in a density column, which is what we did with salty solutions, you had your little test tube and you had layers there, you should see that C goes to the bottom because it is the most dense, that B is in the middle, and A then floats up to the top. Again, just another way of converting a visual look from a density graph from there. That's really what you need to know about these graphs. Don't forget, density equals mass over volume. Density also equals love from there. Density is nothing more than how much matter is given in a given space, and the magical number that you really need to remember is 1.0. Hopefully this helps. If not, please stop down, ask questions. I'd be glad to help you out.